Rust concurrency. Concurrency is hard in most languages. Data races, deadlocks, and race conditions cause bugs that only show up in production. Rust prevents most of these bugs at compile time. The ownership system guarantees that you cannot share data unsafely between threads. This is called fearless concurrency. Use thread spawn to create a new thread. It takes a closure and runs it on a new thread. It returns a join handle. Call join to wait for the thread to finish. If you do not call join, the main thread might exit before the spawned thread completes. The closure's return value is available through join. Threads run independently and might outlive the variables they reference. Rust forces you to move data into the thread with the move keyword. Without move, the code does not compile. The compiler sees that data might be dropped in the main thread while the spawned thread still needs it. You can split work across multiple threads for parallel computation. Divide the data into chunks, process each chunk on a separate thread, then combine the results. Each chunk is moved into its thread. There is no shared data and no race conditions. This is the simplest form of parallelism. Channels let threads communicate by sending messages. Rust uses MPSC channels, multiple producers, single consumer. The channel function returns a transmitter and receiver. The transmitter sends values. The receiver gets them. When all transmitters are dropped, the receiver's iterator ends automatically. Values are moved through the channel. The sender gives up ownership and the receiver gets it. This prevents two threads from accessing the same data. Clone the transmitter to send from multiple threads. Remember to drop the original transmitter so the receiver's iterator can end. Otherwise, it waits forever. You can chain channels to build a processing pipeline. Each stage runs on its own thread. Data flows through input, then transform, then output. This pattern is great for processing streams of data. Each stage is independent and the channels handle all the synchronization automatically. A mutex provides mutual exclusion. It lets only one thread access data at a time. Call lock to get exclusive access. Other threads wait until the lock is released. The lock is released automatically when the mutex guard goes out of scope. Use a block to limit the lock scope and avoid blocking other threads. To share a mutex across threads, Rapid and Arc handles shared ownership across threads. Mutex handles exclusive access. Without Arc, you cannot share the mutex. Without mutex, you cannot mutate the data safely. Together, they provide thread-safe, shared mutable state. You can share any type with Arc mutex, not just numbers. Vectors, hash maps, and custom structs all work. Each thread clones the Arc, locks the mutex, modifies the data, and the lock is released when the guard is dropped. The final result contains contributions from all threads. Two traits control what can cross thread boundaries. Send means a type can be transferred to another thread. Sync means a type can be referenced from another thread. The compiler implements these automatically when safe. RC is not send because its count is not atomic. Refcell is not sync because its checking is not thread safe. Message passing with channels and shared state with mutex are both valid approaches. Use channels when data flows in one direction for producer-consumer patterns and for pipeline processing. Use shared state when multiple threads need to read and write the same data, like counters and caches. Here is a practical example. Parallel word count. Split texts across threads. Each thread counts words in its text. The total is protected by Arc mutex. Each thread locks, adds its count, and unlocks. The main thread collects all results. This pattern scales well with the number of CPU cores. A common mistake is forgetting to drop the lock. If you hold the lock while doing slow work, other threads are blocked. Use a block to limit the lock scope. Lock, modify, then let the guard drop immediately. Do your slow work outside the locked section. Another mistake is using RC instead of Arc with threads. The compiler catches this with a clear error. RC is not send. The fix is simple. Replace RC with Arc. Also, Remember to drop the original transmitter when using channels with clones. Otherwise, the receiver waits forever. Here is a comparison of concurrency approaches. Thread spawn creates a new OS thread. Move closures transfer ownership into the thread. Channels pass messages with ownership transfer. Arc provides shared ownership across threads. Mutex provides exclusive locking. Arc Mutex combines both for shared mutable state. Here is a summary of everything we covered. Thread spawn creates threads. Join waits for completion. Move transfers ownership. Channels pass messages. Mutex locks shared data. Arc enables thread-safe sharing. The send and sync traits control what can cross thread boundaries. The compiler catches most concurrency bugs. In the next video, we will learn async programming with Tokio. Async await is a different way to handle concurrent work. It lets one thread handle thousands of waiting tasks. This is essential for web servers and network applications. You will learn async functions, spawn, join, and select. If you like this video, hit the like button and subscribe for more tutorials.